Hello, intro. This is your chapter 1 review. All right, that's all we've been pretty much working on this quarter. So this is our test on the first chapter. Today we're going to review the first half. In tomorrow's lesson we'll review the second half of chapter 1. I'm going to move through rather quickly. If you need to pause throughout or rewatch this recording to understand problems, please do so. Okay, so here we go. This is everything we went over in chapter 1. We're going to start with turning words into an expression. Remember, addition, we are going to add anytime we see the word some or more than. We're going to subtract when we see these words, difference, less, less than, minus. All right, when we see the word less, that means the minus sign comes after that number it states. All right, so if I have x less, I'm going to have x minus. If I have x less than something, that means that goes after the minus sign. Multiply. All right, we're going to look for words like product of, times, twice. Things like that mean we multiply. When we see the words divided by or quotient, we're going to divide. Anytime you see the word and, it means you're going to go to the other side of the operation that was just expressed. And anytime you see the word is, remember, is means equals. So let's go ahead and look at a few examples. I'll walk us through it. 8 minus the product of, so that means I'm going to be using multiplication, and the product of 9, and I'm going to go to the other side of that operation I just wrote, r. So 8 minus the product of 9 and r. So I can write that as 8 minus 9 times r, or 8 minus just 9r. I would accept either answer. For less than 3/7 of y, right, so for less than, remember when we see less than, the minus goes before the number. For less than 3/7, anytime we see that th, we know it's a fraction of y. If we see of, we think multiplication. So 3/7 is a part of y, so 3/7 y minus 4. The sum of, so we have the sum of 15, and we're going to go to the other side of the operation, x, comma, anytime we see a comma, we're going to put parentheses, plus 7. Now the last one, we have the quotient of, so I'm going to use the division bar, quotient of 12, and I'm going to go to the other side of the operation, which in this case is the denominator, the product of 5 and t. So product, multiplication of 5 and t. The next thing we talked about was order of operations. Remember, we remember this by either PEMDAS or please excuse my dear Aunt Sally, which is what PEMDAS is short for. They both stand for parentheses, exponents, which remember is something raised to a power, like a square or a cube. Then we do multiplication and division. Then we do addition and subtraction. And remember, we always go from left to right, top to bottom. Let's look at some delightful examples. Now these examples are tough, but I want to give you the tough ones now so that the ones you get for practice and homework or practice and the test are a little easier. So notice I have two sets of parentheses here. I actually have braces and parentheses. So I'm just going to think of the braces as parentheses also. I always want to start at my innermost parentheses. So the first thing I want to do is 4 minus 2. So now I'm going to rewrite everything. So I have 3 times 4 minus 2, which is 2, cubed. I did the parentheses so I can get rid of that one set now. Minus 5. I'm still working inside the parentheses, so I have to do the exponent first. I'm still inside the parentheses. I'm still doing parentheses first. But I have to do this exponent because that's my next step. 2 to the third power is 8 minus 5. Again, I still have parentheses, so I must do what's inside of them first. 3 times 3. I have one operation. I can just finish it up. My answer to this question should be 9. All right, this problem here, I'm looking at the parentheses first. I see that I have exponents. So I'm going to do the exponents first. And remember, when we have a fraction, we're always thinking parentheses around the numerator, parentheses around the denominator. So I'm working inside of this set of parentheses first. I should have 22 plus 1 cubed plus, going to do the exponents inside the parentheses first because I'm all the way inside parentheses. My next step is exponents. 3 to the third power is 27 minus 4 squared is 16. Close my parentheses, 2/3. Again, I got to work all the way inside my parentheses. So I'm still inside here. So now I have 22 plus 1/3 plus 27 minus 16, which is 11, over 2/3. Okay, parentheses are all done except for numerator and denominator. So I'm just going to keep the fraction bar there, and I'm not going to do the fraction until the very end. So let's get rid of the exponents now in this step. We have 22 plus 1 cubed, which is just 1, plus 11, over 2 cubed, which is 8. I'm going to go ahead and add the numerator, all right, and leave the denominator since that's all the way simplified. 22 plus 1 is 23, plus 11 is 34, over 8. Now I can do my fraction. I should see that my answer, if I plug that into my calculator, or if I reduce the fraction, is 4.25, okay, or 4 1/4 if I reduce all the way. And then my last example, again, I have 2 sets of parentheses, so I have to work on the far inside. The far inside I have 2 sets of exponents, so I have 3 times 42 minus 2. 10 squared is 100, 9 squared is 81. I still have this deep inside set of parentheses I need to solve for, so I can get rid of them in this step. I have 3 times quantity 42 minus 2 times 100 minus 81, which is 19. Still got to work in parentheses first, and inside the parentheses my first step is multiplication. So I'm going to have 3 times 42 minus 2 times 19, which is 38. Working inside of parentheses still, 3 times 4. My answer should be 12. Hopefully there aren't any questions on order of operations. Again, they were some more difficult examples. I'm working deep inside parentheses. Inside 2 sets, I go in as far as I can. All right, square roots. Remember, square roots look like this. Another term for them is radical. All I need you to do is plug it into your calculator. If we have a square root that looks like this, remember, We can just separate it so that it's the square root of 4 over the square root of 9. All right, square root of 4 is 2, square root of 9 is 3, then we simplify. If we plug that in our calculator, we get 2/3. All right, I understand if you don't memorize these, but you may want to make a cheat sheet of these. These are your perfect squares. Remember, this tells you that if you take the square root of one of these numbers, you are going to get a whole number. You're going to get a positive whole number if you take the square root of one of these numbers, so it's good to know these values. If we look at some examples, square root of 36 over 49, remember when we have the square root of a fraction, we can just split it. Square root of 36 equals 6, square root of 49 equals 7, 6/7 is our answer. If we plug the square root of 196 into our calculator, we get 14. All right, and if I were to ask you to estimate 150, all right, you can then ask you to look at your perfect square cheat sheet and say, well, 144 is a perfect square, and 169 is a perfect square. This equals 12. This equals 13. So the square root of 150 is closer to 144 than it is 169, so it's going to be approximately equal to 12. That's square roots. We have our classification of real numbers, which we went over. All right, remember, a rational number is anything written as a ratio. We have our natural numbers, which are our counting numbers. We have our whole numbers, which are our counting numbers with 0. We have our integers, which are all of our negative and positive whole numbers. And then we have our irrational numbers, which, remember, do not have a terminating decimal. Which means the decimal goes on and on forever. All right, most square roots that can't be simplified, pi, any decimal written with ... at the end, all examples of irrational numbers. So anytime you're asked to put the numbers in order, you want to think of them as fractions. All right, if you plug negative 1/6 into your calculator, it should be like negative 0.16 something. All right, but you'll see that it repeats, which means it terminates. Well, it doesn't terminate, but it repeats, so it is not an irrational number. Because obviously we have a ratio. We have negative 0.3, the square root of 1, which is just 1, negative 2/13, which is approximately 0.15, and then we have 7/8, which is approximately 0.875. If I'm going to write them in order, all right, my smallest negative number is negative 0.3. I wanted to do that in a different color, didn't change. Then negative 0.16, then negative 0.15, then 0.875, and then 1. So I would want to write this in the order that it is given. So negative 0.3 is negative 0.3, this is first. Negative 1.6, this would be second. Negative 1.5, this would be third, this would be fourth, and this would be fifth. Down here, again, we're going to convert these into fractions. The first one I have 3.33, then I have 3, then I have the square root of 8, which is 2.82. I have 2.9, And then I have the square root of 7, which is 2.64. So if I'm going to order them, I don't have any negative numbers here. The smallest number is going to be the square root of 7. So that's number 1. The square root of 8 is the second smallest. That's number 2. 2.9 is 3. 3 is 4th. And 10/3 is 5th. So that would be the order of the numbers. Finally, we have our properties that we have to remember. We have the associative property of addition and the associative property of multiplication. Remember, associative is an association. It's a group of people. It deals with grouping. Associative deals with grouping, so we just switch the grouping as is displayed here. The commutative property deals with order, commutative order, all right, which means we can just switch the order as the example showed below. We have the identity property of addition and multiplication, all right, which says whatever you start with, you end with. So the of addition would be anything you add to 0, you get itself. With multiplication, anything you multiply by 1, you get itself. Multiplication property of 0 states anything times 0 is 0. The multiplication property of -1 states that anything times -1 is its opposite. Good luck, ask questions. We will be reviewing this the rest of the week. Talk to you guys soon.